Hello everyone. Today we're going to talk about our skin cancer identification project. My name is Irene and my groupmates are Elizabeth and Saba. Our motivation and problem statement is that skin cancer is the most common cancer worldwide. In the US alone, more than 2 people die from skin cancer every hour. However, skin cancer is highly curable if detected early enough. When detected early, the 5-year survival rate for melanoma is 99%. Developing a neural network that can identify skin cancer could lead to more people being diagnosed early.
Dataset originates from 7 dermatology centers worldwide, including the US, Spain, Australia, Austria, Greece, and Switzerland. Our data has images as well as information about the patient, such as whether or not it was benign or malignant, the age, the sex, the anatomy site, the color, and the border. Our data set was heavily imbalanced, despite how large it was. Only about 400 of the 400,000 images are malignant cases. Thus, we shortened our data set to the malignant images and 10,000 of the benign images, as well as used weighting in order to improve our recall. The goal is to create a model that takes images as inputs and determines whether or not the image is malignant or benign as the output. Some important data preparation notes are the images are JPEGs. They were resized to 224 by 224 to be compatible with ResNet 18. They were then normalized. 80% of the data was for training, 20% for testing. For model evaluation, methodology, and metrics, the key metric is recall, which is true positive over true positive plus false negative. So maximizing this will result in fewer false negatives. This is important as not identifying skin cancer could lead to a patient not receiving proper medical care in time. Other metrics include F1 score, accuracy, and precision. We coded it using sklearn's metrics in order to print out a confusion matrix and get information on the relevant metrics such as recall. We first started off with handcrafting a CNN originally modeled on assignment 6 and then eventually inspired by AlexNet with 11 layers. A future step would be exploring going even deeper with the layers and increasing the number of parameters. We then decided to use ResNet 18, which is a CNN with 18 layers and residual blocks. It was chosen over ResNet 50 since fewer layers correspond to faster training time. It has been trained on millions of images from the ImageNet database and thus is perfect for transfer learning. The output was modified to produce a binary outcome of benign or malignant.
So for our optimization cycle, we optimized with weights versus epochs. So at first we started with epochs to determine at what point our model was no longer learning and had sort of plateaued. We determined that 20 epochs was the ideal amount. Any more would result in the model sort of losing some of its knowledge. We also tried sklearn compute class weights function. Unfortunately, due to the imbalance in our data set and our prioritizing recall as our main evaluation method, sklearn wasn't necessarily appropriate for the ResNet model. However, we did try several weights around the around the sklearn recommendation and found that 1 in 75, 1 for benign, 75 for malignant weights was the best weight performance. And we tried this cycle several times with different epochs and different weights. So the results of the handcrafted CNN were not ideal as the model sort of learned that as most cases were benign, the accuracy would be best if it guessed benign every time. So instead of identifying malignant lesions, it automatically designated all images as benign. So because of that, we tried the ResNet model with the specific weights. We could have gone stronger on the weights for the malignant cases. However, we found that when we were too heavy on the malignant, the model over-selected malignant on the benign cases as well, and we lost a fair amount of accuracy. So we decided that balance was the better choice. And so while this particular model isn't the best at finding the malignant cases, the false positives are fewer in case of the benign cases. In future steps in this project, we want to get more images of malignant cases since our data set is so imbalanced. We also want to try adding more layers to the CNN, our handcrafted CNN, and then also compare ResNet 18 to ResNet 50. We have no prior work experiencing with identifying skin cancer with a neural network as a group or as individuals. And these are our references. Thank you very much for your time.